Hi, I'm Phil Holland, System Designer for FT Pipeline's Systems Division. Today I'm introducing you to a fuel gas package Class 600 system that is ready for delivery to one of our major clients. At the inlet of the Class 600 system, we have a true double block and bleed system with bridles that allow us to equalize valves, allows us to introduce nitrogen, and allows us to maintain the station fully. This regime exists not only on the inlet, but we also on the outlet of the station have the same arrangement. This will be operating on 44 bar in and controlling at 3.5 bar to a downstream process system. The station is designed for a 95% operational characteristic every year of its life. We're following down to the main safety of the system, which is an ESD valve, which is designed to protect the station should the gas heating fail upstream of the pressure reduction system. Therefore, this is a shutdown system based on low temperature. Looking at the piping system here, we have some redundancy, and therefore the first area that has redundancy is a duplex filter system. This system will remove particulates down to 2 microns, and we have polyprop baskets in each of the filter that delivers that characteristic of particulate removal. Process measurement is undertaken at all sections of this plant. Pressure, multiple locations and multiple temperature readings. Differential pressure is also monitored on our duplex filter system, which again has double block and bleed isolation with equalization to ensure that no mainline valve suffers impingement due to throttling of gas when closing or opening. This is our marshalling system for all the cables from our transmitters and proximity devices. A fully XD system which is then connected via a third party to our client's DCS. We do have future facility for fiscal metering, and this is where the location of a turbine or ultrasonic would be introduced. And again, process measurement all the way through the system. The whole of the system is designed as a plug and play system. We literally can drop this system into place on site, and all that has to happen is plug in the inlet and outlet pipeline systems. We're now moving from the future metering location to the inline heating system. The heater is based upon a hot water circuit operating at 67 degrees in, and we are providing the heat input to ensure an outlet temperature is always maintained at approximately 10 degrees on the outlet to negate the Joule-Thomson effect of the pressure reduction on our regulation system. The vertical heat exchanger is a dual pass, fully rated shell and tube Class 600 system, and we protect any breach of gas to water by having slam shuts located on the flow and return sections. Again, we can isolate this part of the process with our block valves, inlet and outlet, and we have 100% bypass system. Again, all of the safety devices, whether gas or water, have proximity devices to show whether they're open or whether they have closed due to an event. Therefore, the DCS system can monitor the performance of any of those devices, as well as monitoring pressure and temperature. As we move down now, we come to the heart of the regulation system, which is our GasCat Urano active monitor slam shut system. We have a regime of a fail open active and a fail close monitor with a slam shut to give ultimate protection should we have failures on these devices. The system also has a partial relief to account for any creep activities due to the regulators having seat wear, and under lockup conditions this will negate any spurious trips that could occur. Outlet temperature is monitored and controlled by two devices. So should we have a failure of one temperature signal, we have 100% duplication. Therefore, the heating system will continue to deliver under virtually any regime of instrument failure. As we move down to the outlet system, again, the whole system can be isolated by a true double block and bleed system. And as I mentioned at the beginning of this video, this regime exists on inlet and outlet of our system. The whole of the station is designed with low temperature materials, so even under temperature failure, we're not going to have any issues with regard to materials suffering from fatigue due to low temperature conditions, although the system will shut down if we ever see -15 on the outlet with our ESD. We have a wealth of project information and design base on this system, and should you be interested in more detailed specifications or process philosophy information, we'd be very pleased to receive your requests and happy to respond with information that you are asking for.